everyone. Welcome back to this multi-day YouTube series about AI agents. If you missed day one, that's totally fine. You are still in the right place. Yesterday we talked about how large language models work and we did a quick overview about what AI agents are. Many of you asked me to explain AI agents more slowly and more clearly. So today in day two, we will focus on understanding AI agents before we move into the hands-on coding. Think of today as going inside the engine room of an AI agent. We will look at the basic design that many companies use when they build these agents. In the next 20 minutes, we will see what happens behind the scenes when AI moves from being a simple chatbot to acting like a helpful coworker that can actually do tasks. We'll talk about four main parts: the LLM, which is the brain that understands and writes text, the tools, which let the agent call APIs and do real actions, the memory, which lets it remember important information, the planner, which breaks a big goal into smaller steps. By the end of this video, you won't just know the words, you will see how a simple user request can turn into a clear plan and then into a real actions. So grab a notebook, get comfortable, and let's open up how AI agents are built by step by step. Before we go forward, let's do a quick recap of day one so basics are very clear. Yesterday we learned about the large language models are just like a prediction machines. They are really good at writing text, translating code, and answering questions by using patterns they learn from a lot of training data. Now let's look at the limits of a normal chatbot with a real-time example. Imagine you open a simple chatbot and type, "Hey, my sink is leaking. Please find a local plumbing company and book an emergency visit at 3 o'clock today." What will a basic chatbot will do? It will usually say something like, "I'm sorry, I can't search the internet for plumbers, but I can't book appointments for you." Why does this happen? Because a normal chatbot lives in a text only box. It can talk, but it cannot do anything outside the chat. It has a mind, but no hands. This problem is what led to the idea of creating an agents. An AI agents take the chatbot brain, basically LLM, and adds extra software around it. This extra software lets the agent use the internet, read data from databases, and call APIs to press the buttons and complete actions. So instead of saying, "I don't know" or "I can't do that," an AI agent can say, "Let me check that for you and make the booking." That is a big change we are learning about today, moving from just talking to actually doing things for the user. The AI agent diagram shows the four main parts of a modern AI agents. Many beginners think an AI agent is just one big program. In reality, it is set of four pieces that work together in a loop. Let's look at in the middle. There's LLM reasoning engine. This is like a coordinator. It does not store your user data. It reads the data it is given and decides what should happen next in the conversation or task. Second, you can see in the left, tools are integration. You can think of these as the agent's hands. Tools are small pieces of code or web API that the LLM is allowed to call. Examples: if you include a Google search tool or a SQL database query or an email sending services. Third, if you can see that right side is a memory module, this lets the agent remember who you are, what you asked on a few messages ago, and the rules or safety guidelines for your company or agents you are building. Without memory, every message would feel like a brand new conversation because the LLM can't remember what you actually talked to so far. That's why we need memory model to store all your conversation. The last most important part is the planner and controller. This is the part that creates a plan and keeps the agents on track. It stops the agent from looping or wandering and helps it move through the steps in clear order. For example, it actually make the agents what to do next and it does the planning, it does control the agent so that it cannot go beyond what you asked. A simple way to picture this is like imagine a travel assistant. If you go to a travel assistant office, the human intelligence, someone is, and the reception is the LLM. The computer, phone, and web browser, they use it to book your flight ticket. They are the tools. The folders with client details and past trips, they know about your user preference, like you want to sit in the window seat, you want a business class, you want a first class. Those are user preferences are called memory. The checklist they write on a sticky note before booking flights and hotel is the planner. If we remove any of these four parts, the assistant cannot do their job properly. When all four work together, the agent can understand, plan, and take real actions. Now that we know the parts of an AI agents, let's walk through one full example to see how they work together. Imagine the user types. Plan my trip to Singapore next weekend. The step one is goal set. The user gives the agent this goal. What is the goal? Plan my trip to Singapore next weekend. The agent does not jump straight to picking a random flight. Instead, it passes these goals to the planner. So what does the planner does? It actually break the goals into the task. The planner model reads a sentence and turns into a clear checklist, such as like creating the task. Task 1 is check what dates next weekend means. Task 2, find flights to Singapore. Task 3, find hotels in a good area. And the step 3 is calling the tools. Now the LLM looks at the first task, like check what days next weekend means, and sees in real data. It calls one or more, probably it calls date or calendar API. It calls one or more tools such as travel search API or booking a website. These tools return live flight options, hotel prices, and times. The last step is use memory. While this is happening, the memory model is also checked. The agent might find notes like the user prefers window seats and the user often stays at Marriott hotels in Singapore. The agent uses these preferences to filter and rank the options automatically. The last option is create the final answer. At the end, the agent combines all the chosen flights, hotels, and dates into one clear plan. It checks that the time match and that everything fits together, then sends a clean summary back to the user. In real life, a person would open a several browser tabs, copy paste, dates and prices, check different sites and spend a lot of time, checking all the hotels, preferences and all those things. And it probably, as you know that you probably spend 30 to 45 minutes doing all of this. An AI agent can run this whole multi-step process in under half a minute quietly in the background. See, imagine how good it is. Let's zoom in one of the most important parts on AI agent, which is tool use. We talked about tools are nothing like calling a web API, booking, accessing the database, or like all those things. So how does a large language model, which mainly works with words, actually press buttons or do some real calculations? Imagine this situation. You ask an AI to calculate 456,123 times 892,114. If the AI only uses its language training, it just tried to guess, the next character. It might give you a number that looks right, but it may be actually wrong because it is not really doing any maths. Now give the agent access to a calculator tool. With this tool, the LLM sees the math symbol, stop guessing the answers, and instead it creates a simple line of code like return 456,123 times 892 times 1114. The app runs that code using a real calculator, gets the correct result, and sends the result back to the LLM to show you. Tool use is often set up with the frameworks like LangChain or OpenAI agents or CrewAI, AutoGen, all those things. I will have a session about all these framework we can discuss about later in detail. In these frameworks, we define a small text block, for example, a JSON schema that explains a tool. It might say, this is a tool called web search It needs a text search query. The model reads the description, fills in the search words, and then calls the API. This is how we connect creative text from LLM with strict, accurate actions in real world. One of the biggest problems beginners face with AI apps is handling the context. This is why memory management is so important. AI agents use two main kinds of memory to stay smart. The first one is the short term memory. This is a current chart window or current task. For example, if you tell the agent my budget is $500 and then two lines later say find a hotel, short term memory helps it remembers your budget is $500. $500, that's a limit. You need to book a hotel within the limit. But once you close the browser or clear the chat, if you open the new chat, the short term memory is gone. The second memory, what we talk about, is a long term memory. This is the memory that stays over time and it is saved in a databases. It is often uses vector databases. I'll create another video to explain what is vector database. Are similar tools to store files, user profiles, user preferences, and long histories of the first chat, first conversation what you had in the last in the over the days, in the weeks or sometimes a month. Here's a very simple example. Think about an AI customer support agent for an online shop. Short-term memory remembers the tracking number the customer just typed. Long-term memory remembers this customer is a premium member since 2020 and had a return request open last month. So when the agent used both kinds of the memory together, it feels very personal, very aware of context, and much smarter to the user. So how do AI agents work through the hard problems without getting stuck? They use planning. So remember we talked about planning and controller. And there are two different main styles related to planning. One is reactive loops, the second is deliberate planner. Let's explain both in very simple terms with real example so that you can easily remember. So reactive loops, try, see, fix and repeat. Reactive means the agent acts, look at what happened, then acts again. It sees a problem, it takes one small action, it checks the result, then it chooses the next action on the result. This style is often called react, reasoning, and acting. If a tool fails or API gives an error, the agent quickly reacts, changes its plan, and tries another way. I'll give an example. Imagine you are playing a video game level you have never seen before, right? You move forward, you fail, you fall into a trap and lose. You think, okay, next time I'll jump earlier. You try again, jump earlier, get past the trap, see a new enemy, and change your strategy again. You are not planning the whole level from start to finish in detail. You are reacting step by step what you see. And reactive AI agents works in the same way. It makes a move, checks on what happened, and then adjusts. The second, style what we talked about, which is deliberative planners, plan first and act later. Deliberate means the agent thinks ahead and makes a clear plan before doing things. It reads a problem, it writes down the full checklist of steps, then it follows the steps in order. It does checks along the way to make sure the plan is still correct. This is slower at the start, but it can be safer for a big or complex or most important task. I'll just explain a real time example. Imagine you and your family are planning for a long holiday trip, right? So you plan which day you will be traveling, where you're gonna actually stay at hotel, and what you're gonna do, when you go there, right? You write down all of this in a list, or you put a notebook, write it in the paper. Only after the plan is ready, you go and start booking the tickets and hotels. So you are not just figuring out on the way because you are doing it everything in properly. Like when you play video games, you try one level and fail and learn and go for the next one. It's not like that. But here you actually do a complete checklist of what you're gonna do it, and then you take an action. So this is what called deliberate planning. So the deliberate AI agent does the same thing. It creates a full plan, then executes it step by step. I can Sometime you may be wondering that you be whether you will be using reactive loads and delivery planners. No, sometimes you may use both styles together. For example, you are creating a reactive coding agents. So the coding agent, what it says, whenever it says an error message, you can go and change one line of code. It then runs a program, read for a new error, fix the another line, keeps repeating until the program works. This feels like the video games type. Try what, see, breaks, fix and repeat. A deliberate coding agent first look at how the whole project is organized, draw a simple map of the main files and functions, write a list of tests to check all the important parts, then change the code in a plan order, running tests after each change. This feel like a holiday trip example. Plan the route, then follow it. Knowing when to use a reactive style and when to use a deliberate style is a key skill for anyone building smart AI agents. If you want to build your first AI agent this week, where should you start? Don't try to create a science fiction super agents that can do everything. Begin with a small, clear jobs that still have the big impact. Let's say, customer support triage. You can build a simple agent that helps with the support emails. It reads, for example, if you have a small business, you can create an agent to respond to your customer query. It reads new support message from the customer. You can actually search the company, company knowledge base, or documents, and then this it can write a draft reply that answers the customer's question. At the same time, it can create a support ticket and an internal system. This kind of agent saves the time for your support team and is not too hard to build. The second example, you can think of research assistant. You can also build an agent that helps with the research. It looks, you can go into Google and do a search and find out top searches in the topic. It reads the text from those pages, from the papers. It remove ads and promotional content. It can write a short clear summary or report. This is a great for students, analysts, or anyone who often has to read many pages. I think the most important part, I think this is what everyone trying to build it, the productivity as an agent. Finally, you can create a small agent to manage your schedule. It connects an LLM, your calendar and email. I think a lot of people are actually trying this with OpenCloud. It reads incoming meetings, invites, and messages. It decides which times fits your working hours. It accepts, declines, and suggests new meeting times automatically. This type of agents helps you to stay organized without checking every invite of every meeting invite from yourself. Designing your first agent, I would say that the architecture consists of four questions. I actually call it as SAPG, which is scope, access, persistence, and guardrail. First most important thing, what is the exact scope of these agents? Make it very narrow and specific. Example, answer basic customer questions. If you're building a customer support uh, bot agents, or plan travel for sales staff. If the scope is too wide, the agent becomes confusing and hard to control. So make it as a very simple, narrow, and specific. The second most important thing, access. So what kind of systems the agents would have access? So you need to list the things like which folders or files it needs to access, which API it needs to call, which what are the databases it needs to connect. You will create a tools only for these approved places, so the agent cannot wander into anything, because you clearly define these are the tools, list of tools in the system the agents would have access, so that agent cannot go behind. The third most in this persistent. What information should the agent remember over the time? Decide what needs to be stored in the vector database for long term, what needs to be stored for short term. So the like user profile and preferences for long term, the important past tickets and tasks, key documents or notes. This lets the agent stay useful across many login sessions, not just for only one chat. The last but not the least is the guardrail. This is about safety and cost control. Without guardrail, an agent which with tools could call the API and again in a loop and waste a lot of your money, because it can call the same API again and again, and it does the repeated actions. It might burn all of your tokens. So make a wrong change in the code database, okay, it can go and make a wrong update in your database, run for hours when it should stop after minutes. So you must add rules in your code such as limits on total number of API tokens or requests, maximum number of steps or time per task, a required human input okay for before any dangerous changes like deleting the data or sending emails to many users. These are the things human in the loop needs to be included. These four questions like scope, access, persistence, guardrails are the basic checklist every good AI agency should start with. So fantastic job, everyone. You have finished day two of the series. By now, you understand the main parts of an AI agent's, um, memory and LLM and tools and planners and persistence layer and everything. What are the tools? It's not. These are the main parts of AI agents. Discuss on how the planner and control works. What are the different styles of an AI agents? You learn the basic theory and architecture. That means you are ready to start writing code. But I don't want to get into a code next time because I think we talked about before building a agents. Let's learn about the agent framework, and let's give a deep dive about why you need an agent framework and all those things the next session. Thanks for staying with me. If you like this video, like it, please give a feedback. If things are not clear, if you need more explanation, if you need more any, if I explain anything wrong, feel free to add a comments. Thank you.